Hi everyone, welcome back to another
Hello.
Friday, another coffee time with crypto. Mr. BTCBC and here, my good friend DJen Ben, just to bring you another
Hey.
episode.
Yep.
How's it going, buddy?
It's actually looking good. Everything seems to be stabilizing. My degen plays seem to at least have stopped dropping.
Yeah.
So what do we have today?
Well, so I was thinking we were gonna go over some layer ones. So there's so much to
Wow.
talk about, but I kind of don't know where to start either. So like I'll field questions from you, and then once I'll kind of segue into anything that I can think about.
Like for me, just for educational purposes, like I think the first thing I want to know is like, is there a layer that precedes layer one?
Sometimes it's called layer zero. So
Okay.
that layer zero is essentially it kind of refers to anything that's like infrastructure where it does like it does cross chain.
Does cross. So for
So like
example, like
layer ones would be able to interact with those layer zeros.
interesting. So, like, just to say, like, Ethereum itself
Yeah.
would be considered layer zero.
So Ethereum would be considered layer one. Layer ones are usually security layers,
Okay.
and that just means that's like the primary role of the the validators or the miners on that blockchain is
Okay.
to provide security for the applications that are built on that blockchain.
So, what would be the layer one, layer zero of Ethereum?
So, uh, so that we're talking about different blockchains here. So
Mm-hmm.
Ethereum as a blockchain is considered a layer one.
Yeah.
It doesn't have a layer zero per se,
Oh,
but there are other
okay.
blockchains or other types of blockchain related projects that
Okay.
call themselves layer zero. So things like
Oh, okay.
Polkadot and Cosmos, these projects are layer zero because they allow other blockchains to interact with each other through them. So they're built
Okay.
on top of the layer zero.
So,
And
would like bridging be sort of a function of a layer zero?
it can
Okay.
facilitate a bridge. Um, yeah, so like I mentioned for Cosmos, any blockchain that was built using the Cosmos SDK, if they turn on the IBC, they can have interoperability through that osmosis network.
Okay. Cool. Because like from my perspective, when I was looking at layer one, it's like, okay, layer one is basically the most well-known coins out there, like the
Yeah,
avalanches and the phantoms and those.
yeah.
But then I wasn't really sure, like, number one was what level zero was, and then what, like, what would be considered a level two if we use an example of a very popular coin as
Okay.
level one.
So layer two refers to uh, scaling solutions. Okay. So
Oh,
for Ethereum being the L1, the
okay.
layer two, you would have Optimism, Arbitrum, ZK Sync. These are like there's a bunch of layer twos, and um, they all kind of work a little bit different in terms of how they um, how they perform that scaling work.
Okay.
Right?
So, like for an example, would you have an example of like what's the most common, most well-known layer two that's currently out there, or for Ethereum?
So the ones that I mentioned as well,
Hmm.
Polygon would also be um,
Polygon. Okay.
considered a layer two, even though they're a layer one in themselves. So
Hmm.
the ones that I mentioned before, like Arbitrum Optimism, they um, they don't use their own validators. So what they do
Oh.
is they use things that called roll-ups, and the actual validating of the blocks are still done on Ethereum. So that would
Oh.
be a true layer two. Um, Polygon is more of like a side chain where
Mhm.
it has its own validators.
Okay, and knowing that, what do you see? Like, we all know, like, hey, level one, you have all these coins, you have all these protocols that are all within layer one. Like, what would be the use? Like, you said like optimizing the layer one is one of the functions of potentially for a layer two. What, like, as an investor, like, what do you look in? Like, what do you look for when you're like, oh, you know what? Maybe I should diversify my portfolio, put something into layer two. Like, when people say that, what are they saying? Because I don't know what I'm talking about right now.
So I think the approach, at least for me, that I had was I looked to see what are the existing problems with
Okay.
the OG blockchains, right? Like the
Okay.
um, Ethereum 1.0 on its own is not built to scale. And
Okay.
so first you have to define kind of what that scaling means.
Hmm.
But before we talk about scaling, it the general problem with Ethereum is that it's slow,
Yeah, and the gas fees,
right?
right?
You have a lot of transactions that want to be processed on
Hmm.
Ethereum, but it's not built to handle those transactions quickly. So then you have a
Okay.
buildup of transactions. People will then fight for block space. So
Uh-huh.
in a blockchain, basically every single block, you're just putting all these transactions in.
Yeah.
And if you have a limited amount of space in that block and everyone's trying to fight to get their transactions processed.
Hmm.
If you're not processing, if you don't have the capability to process these transactions very quickly, then um, the demand for wanting those transactions to get processed drives up
Hmm.
the price, and that's why people bid higher and higher gas prices. So I'd say those things come hand in hand.
Okay. So is there like a layer two in your mind, on the top of your mind right now, that's trying to deal with this for Ethereum?
So all of them are right. Okay, so
All of
once
them.
you
Oh.
okay, so you kind of have to think about why these blockchains were designed with a particular block size and a particular block time,
Hmm.
right? Because uh, you could scale a blockchain by just doing something very simple by increasing the block size. So how many transactions you can shove into one block.
Okay.
Okay. So then when you process that one block, you're processing, more
Hmm.
transactions, then you've effectively scaled that blockchain. So the reason
Hmm.
that, I mean, that's not done is because um, everything that goes on a blockchain is recorded and never discarded.
Hmm.
At least the, the blockchains that we're familiar with. So
Yeah.
if you have very large blocks, that means that you have very high storage requirements for
Hmm.
anyone trying to run a full node. And these things
Oh.
it just becomes very inefficient.
Yeah.
So that's why, there has to be some kind of compromise that has to be made. You know?
Okay.
And, you know, the block time really has to do with, how fast the network can reach consensus. Okay, so
Mm.
um, when in a proof of work system, okay, you have mining, and
Mhm.
the miner who solves the puzzle, okay,
Yeah.
um, that gets them the right to add a new block to the blockchain. So regardless
Mhm.
of whether you're a proof of work blockchain or a proof of stake blockchain, um, there has to be a mechanism to
Yeah.
choose someone who has the right to add a block to the blockchain.
Okay.
Okay, so in a proof of stake system, that person would be called a validator, and in a proof of work
Mhm.
system, that person would be called a miner.
Yeah.
most blockchains, or at least Ethereum, okay, that will say, and Bitcoin, they have
Mm-hmm.
memory pools. So like a miner would have a memory pool where if you create a transaction, your transaction will be added to the memory pool. So
Uh-huh.
so a bunch of other transactions which has not been processed yet. So that's why
Okay. Yeah.
when you send a transaction, it goes like
It's
pending,
like
right?
pending, right? Yeah.
Yeah. So then it's inside the memory pool of some miner out there,
Okay.
right? And then what happens is, the miner who has the right to add the block can choose which transactions to add to that block and in what
Mm,
order, right? So they
okay.
would do it in a way that
It's more,
maximizes their benefit.
yeah, most profitable, right?
Yeah. Okay. So that's why if you pay a higher gas fee, then they'll choose that transaction and add it to the block. So that's kind of how um, that works,
Yeah.
right? So the person who, well, the miner or validator who adds the block, that the new state of the blockchain has to
Hmm.
be communicated to at least two-thirds of the nodes,
Okay.
okay, in order to have a new consensus
Yeah.
on what is the proper state of the blockchain.
Okay.
So in Bitcoin, that would be 10 minutes.
Cool. Okay.
And in Ethereum, you have like 14-second block times,
Okay.
right? But 14 minutes, 14 seconds is still too long. Uh,
Hmm.
and I think, well, in Ethereum 2.0, I think they're going to try to reduce that by a couple seconds. But you still have um, other blockchains and Ethereum sidechains that try to reduce that block time.
Mm.
Okay, so Polygon has like a 1 second block time.
Oh,
Yeah.
and I'm guessing like the chain itself can't just say, "Hey, this guy's doing it this way. Let's just copy that." Like they can't do that, right? What's stopping Ethereum from just adopting what Polygon is doing and just make it their own?
Oh, because Polygon is a proof of stake network,
Oh, and
and
Ethereum is still
so
proof of work.
so
I
it
know.
can arrive at a consensus faster than a proof of work
Okay.
network, right? So you
Okay.
generally
Okay.
will
Okay.
see that proof of work networks because they actually
Mhm.
have like will be slower than proof of stake
Okay.
networks.
Okay. And I guess the next logical question is like, how like when we talk about proof of stake, which is what I guess Ethereum 2.0 is moving towards, what is the like how is it like so much faster? Like instead, like we know that miners, they just use their computational power to like solve complex, like I guess, equations,
Yeah.
and that's how it works. But what's so different about proof of stake that it's so much faster?
So let's hang on for a second there.
Okay.
Um, so I don't think Ethereum 2.0 is going to be that much faster,
Oh,
uh, because like I mentioned before, the block times are expected to be around 12 seconds,
okay.
something like that. So it's still not going to be like 1 second or sub 1 second like you have
Okay.
in some of these other um, L1s. Okay.
Mm-hmm.
But what Ethereum 2.0 aims to do is it aims to scale Ethereum, okay, um, by using by using the sharding stuff. I think, I mean, we did mention it in some other
Hmm.
videos.
I came across sharding. I tried to read into it, and I'm like, nope.
I actually wanted to kind of talk a little bit more about what makes each of these L1s different, right?
Yeah, let's talk about that. Let's
Because
save the sharding part to something else.
because because like scalability is part of it, but
Uh-huh.
scalability in itself is also like its own topic. So we can like
Hmm.
go down too far down that rabbit
Okay.
hole. Okay? So
Okay.
like the first thing I would say, if we were to look at L1s, is um, kind of what they are trying to achieve, right? So
Mm,
some L1s they aim to be like a public blockchain, and
okay.
for example, Ethereum, Bitcoin, these are public blockchains, right? So they aim to be the public security layer, and what it
Mm-hmm.
means is that anyone who makes a transaction on Ethereum, everything is public. Right? You can go on
Mm-hmm.
Etherscan, you can see the entire chain, and anyone can run a full node and have the entire history of that blockchain.
Uh-huh.
Right? You have other chains, well, other I guess L1s that they will have both. Well, they'll try to target both private and public uh, blockchains.
Okay.
So something like Avalanche, they
Mm-hmm.
they have a subnet kind of system where um, you can have a subnet where uh, you can have your own validators, and if you have one validator and that's it, then you're basically like a permissioned uh, system. So you can have like a
Oh.
private blockchain that is running the Avalanche consensus mechanism,
Mm-hmm.
um, and it has nothing to do with uh, the Avalanche C chain that you or most of us who are using Avalanche are familiar with.
Like, but what else? What would be the uses of like the private part?
So like I mean, if you're a business, okay,
Yeah.
and you for any reason you wanted it to have a ledger that's immutable, okay, and
Mm-hmm.
uh, so blockchain technology is a good way to do it. Okay, when we talk about Avalanche, remember what they're not a blockchain per se. What
Mm-hmm.
it is they're a um, they're a DAG. This I found a useful diagram. So this is basically a DAG. It's called a directed acyclic graph. What it is
Mm-hmm.
it's very similar to a blockchain. But it's just not linear. Okay, and
Okay.
um, a DAG is this tree which never has a cycle. It always
Okay.
just flows downwards like this. Okay, so you have that kind of structure in
Mm-hmm.
essence like a blockchain, but it doesn't have to be linear, like one block after
Mm-hmm.
another block.
And is there a reason why they chose to do this, or
I
it's
think it's
just
just more efficient. Like
mm,
you don't when you're a proof of work blockchain,
mm-hmm.
then it kind of makes sense that you're linear one after another.
Yeah, so you have to sort through the whole chain before you
Yeah,
finish your work or whatever.
but I think it has like benefits of being much faster and
Mm-hmm.
um, you don't have to like wait for things.
Okay.
Remember, I'm like not a blockchain expert. I'm just
Yeah.
like I just do a lot of research myself. So
Mm-hmm.
hopefully as DJ Ben and I are kind of just chatting about these things and kind of like teaching him some of the stuff that I know.
Mm-hmm.
Some of you guys can gain something out of this as well.
Yeah.
So, yeah, going back to why a business would want to use a private chain, it's just like
Yeah.
a blockchain at the end of the day, or a DAG, is just like a ledger. So,
Mm-hmm.
if for any kind of business reason, if you wanted to like put your entire inventory on it, or some kind of
Mm-hmm.
if you're using some form of a database, you can use a blockchain.
Mm-hmm. Yeah.
And like what Avalanche does is it allows you to choose if you're a blockchain that you want to create, you can choose for it to be validated using the primary network that they have.
Mm-hmm.
So the primary network, they basically have like three main chains right now on their
Okay.
primary subnet. Um, and that's their X chain, P chain, and C chain. Have you heard of
Okay.
these?
I've only heard of C chain because when I was setting up like MetaMask, everybody was like, use the C chain, and I don't know what the difference is between
Yeah.
them.
Okay. So the C chain is a kind of like a special chain that is validated using the primary network of
Okay.
Avalanche validators. Why is it special? Is because it uses the Avalanche consensus, but it is a linear form. So it's not a DAG.
Oh,
What's Yeah, because they have their EVM. So if EVM means Ethereum Virtual Machine. So
yeah. So
they're
they're just
so
copying what EVM does, like
yeah.
what
So
Ethereum does.
so in order to run the EVM, because Ethereum is a proof of work linear
Yeah.
blockchain, in order to kind of run that EVM, they have to also make it linear.
Okay.
Um, but the validator set is still using the primary network, and then
Mm-hmm.
the X chain is the native, like um, it's where like the AVAX token is native.
Okay.
And then the P chain is like they call it a platform chain, if I remember correctly, is like if you wanted to build a your own blockchain, then could be on uh, the P chain or something like that.
Okay.
And don't quote me on that.
Yeah, it's okay.
Yeah, like I said,
Mhm.
I'm not like an expert on every single little aspect of blockchain.
Okay.
Okay. So that's like kind of the first difference, because
Mm-hmm.
some blockchains they're purely public, and then some
Yeah.
their approach is they they want to um, they kind of want to solve more problems than just like a kind of like the public ledger.
Yeah.
Okay. Then the second thing is like we kind of touched on it, like whether they're currently EVM compatible or whether
Mm-hmm.
they're non EVM. Um, and Avalanche again, they have their C chain makes it EVM compatible.
Yeah.
Yeah. But then you have other chains like Solana, which is at least currently not EVM compatible.
Okay.
Um, I guess like there are some layer zeros that um, were not EVM compatible, but like there's a there are EVM compatible blockchains that are built on them, and
Okay.
then they become EVM compatible.
Just through whatever's been built on them.
Yeah.
Okay.
So it used to be that like if you're an investor, a couple of years ago, that was one of the things that I personally focused on was,
Yeah.
finding blockchains that were EVM compatible, because everyone had only heard of Ethereum, if you're doing smart
Yeah.
contracts. So if you're not compatible with Ethereum, then it was very hard for the dApps to migrate
Yeah.
over to your your
Mm.
system. So you could have the best technology, but then you'd have
Yeah.
nothing, like no dApps on your blockchain,
Yeah, because
like
you're not
no
popular
users.
enough.
Exactly.
Yeah.
Yeah.
Okay.
So then like another thing would be like the security.
Mm-hmm.
So security is obviously very important. So that comes down to, yeah, how many validators you have,
Yeah.
how decentralized those validators are. Um, if we're talking about, so L1s mainly going to be focused on like the popular ones, right? Like
Yeah.
the popular ones in my mind right now are like, or at least most people, if you look at top 10, there'll be like
Mm-hmm.
Avalanche, Solana, Terra.
Yeah.
Any ones that, or the Cardano's up there, but I'd say it's not as interesting for most people. Like, what do you think?
Okay. I've actually not even touched about anything on Cardano.
Yeah,
Like I remember back in the day where you told me about like Kusama, like all these other things, but when I actually tried to go into crypto, it was just like, hey, these places are kind of like the wilderness. It's like
yeah,
if you want to farm, it's always either AVAX. If you want to do anything sketchy, you'll go to Phantom. It's just there seems to be no like natural road that takes someone away from AVAX, Phantom, or Ethereum, or Binance, and just take them and go to Kusama or Cardano. Like I've heard from other YouTubers, they're like, "Oh, these are like top blockchains and everything," but
Yeah.
at the DGen, like there's like nothing on them.
It's not just for degens. I think as a user, you go
Yeah,
where there are things to do,
yeah.
right? So that's why if all the dApps that you're familiar with or that people are talking about are on Ethereum or EVM,
Yeah.
then that's all you're gonna really know about. But that's not to
Yeah.
say that there's not like that's why I go back to what kind of problems these other chains are trying to solve.
Mm.
Mhm. And that's why like for example Avalanche, going back to Avalanche, the reason why they have an EVM chain, I think it's really just so that people know about them,
And we'll
right?
use them at least.
Because and they're interoperable with Ethereum. But really, in order for like the Avalanche blockchain to really succeed on its own,
Uh-huh.
it really comes down to whether people want to create new blockchains on them, whether there are other public
Mm.
blockchains or private blockchains, and use their system of um, subnets, right? Whether they want to create um, their own subnet of validators using Avalanche's
Mm.
consensus, okay? um, or they want to use their public set of validators. So like that the different consensus mechanisms, like we talked about how it affects the speed, right?
Mhm.
Because remember, if you need to add a new block and then pass on that information to two-thirds of the nodes, that's going to
Mhm.
take some time.
Yeah.
Um, with Avalanche, what they do is they take a more probabilistic approach. They kind of sample the nodes, like instead of
Well, instead of going through the whole
yeah,
chain, I'll just like do what auditors do. I'll just pick a representative sample of nodes
exactly.
and see if they match, then we're
Yeah,
good.
exactly. So they
Okay.
take a random set of nodes
Uh-huh.
to see if those nodes agree on the state,
Mhm.
and then they form a consensus that way.
Oh. Okay, actually, this is a really good. I think this is quite interesting. Like first we were talking about like how Avalanche is trying to make it faster, basically through this, I guess, sampling type of to approve or finalize the transaction. So, what would some of the other L1s like? What are they trying to do? I think as someone that getting into crypto or whatever, at least we should know what each layer one chain, like the popular ones,
Yeah. So
what are they trying to do?
which ones are you most interested in, right? Like
Like, so
that.
you mentioned Solana, right?
Yeah. So Solana is much more interesting because what Solana uses a completely different consensus mechanism. So it's not proof of work, it's not proof of stake. It's actually
Okay.
something called proof of history. Hopefully this works. It's going to be the first time we're playing a video.
Proof of history enables the blockchain to work fast while maintaining security and decentralization. Here's an analogy. If snapshots of dye diffusion were scrambled, you would know how to place the resulting images in order again because of the laws of entropy as a function of time. Proof of history uses a recursive verifiable delay function to hash incoming events and transactions. Every event has a unique hash and count along this data structure as a function of real time. This information tells us what event had to come before another, almost like a cryptographic timestamp, giving us a verifiable ordering of events as a function of time. Each node gets a cryptographic clock that helps the network agree on time and ordering of events without having to wait to hear from other nodes. Unlike slower, traditional blockchains, oftentimes throttled by various consensus mechanisms, Solana achieves high throughput without sacrificing network security. Visit solana.com to learn more.
All right, so let me just try to explain it. What proof of history is it's saying for every single time they perform like a cryptographic transaction, there will be a timestamp. Using this timestamp that they create, they will construct like basically a clock
Okay.
that will order the transactions so that every single Solana validator, when they receive this information, they can use those timestamps to recreate the order in which the transactions were made.
And everybody is sent the same like flow of orders, I guess, flow of transactions based on the timestamp, like the validators, I guess.
Yeah, so in order for um, a node to to be able to reconstruct the state of the blockchain,
Mm-hmm.
you need the data and you need to know the order of that data.
Yeah.
Okay, so uh, in Ethereum or in Bitcoin, like the nodes, they're basically verifying the entire blockchain.
Every single time, right? Every single transaction, they run through the same blockchain and maybe add something on the end and run it through it again or whatever.
Kind of, yeah. So that's how they make sure that they have the correct state of the blockchain.
Yeah.
But so in Solana they use this proof of history. So instead of having like a bottleneck where everyone
Uh-huh.
all these nodes they're waiting um, for for the state of the blockchain to be propagated through all to
Uh-huh.
the 2/3 of these nodes. So it can be like simultaneous, like it's more like parallel processing.
But wouldn't there be like a big lag if something wrong happens along the way? Like,
No, so
what
like
if?
I mean, so imagine you have like a lot of data that you
Mm-hmm.
need to process, right? Um, and you you can if you need to process them in the right order, it can either
Uh-huh.
come in the right order,
Yeah.
and you're processing one by one,
Yeah.
or um, they can be thrown at you in parallel. Let's say you have the ability to process things parallel. So
Mm-hmm.
so one of the differences that Solana has is that it actually requires like very expensive computing like computers to run like a node.
Oh, okay.
Okay, the reason is because of how it's designed. Like you need to be able to process a lot of information in parallel. Okay,
Okay.
but when you're getting all that information in parallel, how do you know what order they're coming in?
And that's based on the
Right.
timestamp that
So
was created.
that's what the internal
Okay.
clock of the blockchain is for.
Okay. Okay.
Right. So that's why it's faster because you're basically doing things in parallel.
Yeah.
Okay. So with Solana, um, what they what they don't have is they don't have a memory pool. Okay. So when you're
Mm-hmm.
sending a transaction to a Solana RPC node, you're uh, y- you're basically just spamming them. Okay,
Huh.
and all Solana transactions are the same price, like their same fee. You don't have
Okay.
a variable fee, like you can't set like a higher gas fee to
Mm-hmm.
show the validator that you
It's
want
like, hey,
your
process
transaction.
me.
Yeah. So instead, what it is everyone just spams them.
Oh.
Right? Because um, so when you're only counting the valid transactions, like the
Mm-hmm.
transactions that actually get through,
Yeah.
then those transactions per second are much less.
Oh, okay. Okay.
So this is like
But
it's also a huge problem for real life usability of the Solana network because like whenever they have this like huge NFT airdrop or something like that,
uh-huh.
um, and where everyone's just trying to mint
Uh-huh.
NFTs, or there's like huge market volatility, and you get a lot of congestion because all these bots are basically spamming the network, causing denial of service.
And then when you say spam, they're just trying to keep on sending the same transaction until it goes through.
Yeah. So like
Mm.
I've tried to send like 10 transactions, only one of them would go through, right? So you just have to keep on trying with Solana.
What?
Whereas on so normally it's very fast and basically essentially free. It's
Mm-hmm.
so cheap, it's you don't even think about the transaction fees. But for a blockchain like Avalanche, in times of congestion, they just make you pay more.
Yeah.
So if you pay more, then your transaction will be processed and it'll be
Mm.
just as fast.
Okay. Okay. So I guess you can kind of say Solana is like more fair.
Yeah, but when as a user, it can be like highly frustrating.
Yeah.
Yeah,
Yeah.
and the whole network goes down. So it's it's they like as I was doing research for for this content, um, I did come across like things that they were doing to try to
Mm-hmm.
solve these kind of issues. So like I believe that they are, the things that are in the works are like a variable fee, so that you can,
Mm.
assign a higher fee to certain transactions, or things like, um, I think some of these things they already have, but maybe they're making like further improvements on. So
Okay.
they can do things like find duplicate transactions. Yeah.
Mm.
So I don't know if that's something that has been already implemented or something that they're doing, but I think, so it's definitely an area that they're looking to improve. Is so that if everyone's spamming the same transaction over and
Yeah.
over again, like if you can find out all the duplicates, then you
Mm.
remove a lot of the spam.
Okay. And like, what do you see as like the best use case that people are using Solana for? Like, is it what I think from what I heard from you was like a lot of people just day trade on Solana because
So
of the speed and cheap fees?
so Solana has, the benefit of like a very 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 high throughput, which is the
Mm-hmm.
transactions per second that it can handle. Uh, So one of the things that requires that level of throughput is a central limit order exchange.
Mm.
So what we touched on that before, and I would say, yeah, like they have this, a DEX called this Serum. So Serum
Okay.
DEX. So it's basically this order book which, any of their other dApps can tap into. So a lot of their
Oh,
exchanges on Solana actually can integrate like the Serum order book. And you even have
okay.
like there's a dApp called OneSoul, and it even like aggregates the swaps, so liquidity pool systems with Serum's order book, which is really cool because then
Oh,
you can always get the best price. Um,
oh, that's actually really cool because you
mm,
actually have apps working together.
yeah.
Nice, nice,
Um,
nice.
so I think we like touched on quite a lot about L1s, and it was a little
Yeah,
bit of a mess because there's just so much out there
yeah,
and we're not that organized. We'll try to get better. It's difficult when a lot of these things are like highly technical and we're not like the developers and we're not blockchain specialists.
yeah.
So uh, well, what I'm trying to do is I'm trying to understand it to the level where, uh, like a informed investor should be,
Mm,
or someone who is interested in the technology and wants to know kind of, where the future of Web3 is headed. So that's kind of where, um, hopefully the things that we discuss, some of it you guys find interesting and that you can learn something.
yeah, instead of just being a DJ and just buying whatever hype.
All right,
All
so
right,
we'll see you guys next week.
all right. Later.
Take care.